Well, what you actually do in this lab is really simple. You're actually just supposed to print out this and draw and so measure the components with a ruler. So, for example, this is displacement, this one, and put on paper and measure this one. So if this is a 2.2 centimeters, I just, for example, I'm not actually measuring, but I want you to do it. So in this one is 1.5, and then you will say 2.2, and then 1.5, put in there. Now do this one, and so if you draw a little triangle here, vertical distance, so this will be, say, 1.5, and this one will be 0.1, something like that. And this one, realizing it is a negative, okay, because in y direction is going down, so which is negative. In x direction is also going down, so this both will be negative. Just to give you some sample numbers, it will be negative 1.7, so it's negative 0.9, for example. So of course yours should be much more accurate. Actually, I already handed out the printout. You just measure that paper and scan it and store it here. And to the next question is, the vector can also be represented by the magnitude for the strength and then an angle, and put this in a curly brace. So the direction of the vector is specified with angle it makes with x-axis. So realizing that this is the protocol, you always measure the angle from the x-axis and that way, okay, which means always a positive number from 0 to 90 to 180 and all the way to 360. So you never use a negative number for this. So of course, in some other area, you can use a negative number. It is equivalent, but here as the convention, you always use a positive number. So from 0 to 360 degrees. And first, you estimate the angle. You can estimate the angle and put the angle here. For example, I did this, 47. Doesn't mean exactly 47, just I think it's 47. So you write that. It's very easy. And then you again print this out with print this out, and then with these you measure the length with the paper. Okay, and then after that you will what you will do, you will express, for example, first one, I want to measure actually the length as the strength, so it's magnitude and angle, and magnitude and angle. So that's another way to write this on the paper. Well, this is more straightforward because vectors are nothing but quantities that has magnitude and directions. So you have magnitude and direction, magnitude, direction. There are 10 of them. I have done the first one. So, for example, this 47. If I try this, and that will be, so I draw a line here. So that's 47. So this will be something like this. No, this time I measure this. So this is like 3.1 centimeters if I measure on the paper, print out, and then I have 47 degrees. So then so I write here. So I have done the first one, 47, and 3.1 is the magnitude, 3.1, and then 47, or I'll write as I have written here. So for the first one, so that for the first one. So then you're supposed to do every one of this. In other words, just make sure you, I think after doing 10 of these, and you get what I'm trying to say. You represent the vector this way. And of course, in the class, we will study how do you convert between this magnitude and angle representation and the components representation. Then you will involve in the trigonometry. cosine, and sine. So for now, after this lab exercise, you can, very well mastered the vector representations by components or by magnitude and direction.